In this new tutorial, we are going to create an ESP32 smart home project that allows you to use the Wi-Fi capability and control some devices using your smartphone. As you can see, I can turn on and off these LEDs that you can replace with home appliances that works with a high voltage using the relay module, and we will add the manual switches to turn them on and off as well. Finally, we will have this button that turns all of the devices off when we press it. And that's really useful for a home project. So before we get started, make sure to smash that subscribe button. That helps me a lot. And without any further ado, let's dive right into it. First, you have to download the project from the link under the description. It is under my GitHub account. You will find the sketch file as well as the circuit schematic. Let's open it up. As you can see, I have connected 4 LEDs to the pins number 16 until number 19. If you want to control some high voltage devices, you have to connect these to the relay module. And on the other side, I have connected a 220 ohm resistor to protect the LEDs. And we finish up by connecting the other side to the GND. Then we'll be able to control these LEDs or the relay module with the help of the Wi-Fi capability that comes with the ESP32 board. And you could use the manual switches. That's why I have connected these 4 push buttons. One lead goes to the ground and the other one to one of the GPIO pins. For example, I have connected the first push button to the pin number 12, the second one to the pin number 14, 26 and 27. I have mounted the ESP32 board on this breadboard so that we can easily connect these components. I have the 4 push buttons. As I said, one leg goes to the ground. I have connected it to the ground rail, and the other lead goes to the pin number 12 for the first push button, 14 and so on. You could also use other GPIO pins if you want. The same thing, I have added these 4 LEDs. I've connected them as the circuit schematic. Now we can move on to the code and check how it works. On top, I have included some libraries that we need for this sketch. The first one is the Wi-Fi library to connect it to the Wi-Fi network. The next 2 libraries are used to create a web server that listens to clients. So whenever you type in the IP address of the ESP32 microcontroller, this server will show you the buttons. In this case, the ESP32 gets connected to a Wi-Fi network, like the router network. That's why we have to provide it with the SSID and password of the router. As I said, you have to type in the IP address of the ESP32 microcontroller, and it allows you to get the buttons and the state of the LEDs. The same thing applies for computers that are connected to the network. But these 2 libraries are not built in. You could download them from the link under the description. So this is the link of the ESP Async Web Server library. You have to go to code and download it as a zip file. The same thing for the Async TCP library. And go to Sketch and include libraries. As you can see, we have the option using a zip file. You could simply select the library from the downloads folder and hit open to install it. I've already done that for these 2 libraries. The last one is called ESP-MDNS. Anyways, you have to type in the SID and password of your Wi-Fi network. Then I have created this web server using the Async Web Server library that takes the port, which is port 80 for an HTTP. The second object is Async Event Source, which fires an event whenever we press one of the push buttons and update the state of the LED. And it will tell all of the clients, which are these devices, to change the look of the button if we turn the LED on and off. Finally, I have added this device object, and it is used to simplify the coding part. Basically, each device has a pin, like this LED is connected to the pin number 16, and we have to keep track of the status of this LED if it's on or off. That's why I have added this tracker device that contains some properties. So each device has a pin, a button pin, whether if it's on and off. This integer represents the ID so that we can identify the different devices. Next, we have created 4 devices using this kind of type, tracker device, and we pass in the properties. For example, the first LED has the ID 1, the pin is pin 16, and we can control it with a push button that is connected to the pin 12. By default, all of the LEDs are off. That's why I have added 0 by default. And that's pretty much it. So the rest of the code is responsible for displaying the HTML page and it is checking whether the LEDs are on or off. Under the setup function, we have used the pin mode. I highly recommend you to read this code so that you can understand how things work. Anyways, once you change the SID and password, we can select the kind of board that we are using. For me, it is a Node MCU 32S and the port of the USB cable. And let's hit upload. For some ESP32 boards, you have to hold down the boot key, which will start uploading this code. We have the percentage. Once it's done uploading, we have to get the IP address of the board, and it is printed on the serial monitor that you can open up from this icon. I have used the baud rate 115-200. Make sure to select it. Then let's reset the board. And here's the IP address. As you can see, it is connected to the network. Now we can copy it using Ctrl+C and use a web browser like Google Chrome. Of course, you have to be connected to the same network. I've already done that. And there you go, we have the ESP32 Smart Home project. We can turn on and off these LEDs. The same thing, we can use these push buttons. And the state is updated. Also, we have this useful button that allows you to turn all of the LEDs off. Let's press it. And there you go, it is working. So before I finish this video, I want to mention that you could use a name instead of the IP address. So this address could change and you could easily forget it. And that's the purpose of this library, ESP-MDNS. Under the setup function, it is used to create this kind of name, ESP32, and you could change it. Then you can simply type in ESP32.local to access the same web page. So let's give it a try. I'm gonna type in ESP32.local. And there you go, we have the same web page to turn on and off these LEDs. I think that's pretty much it, guys, for this video. If you have any question or comment, make sure to write it under the comment section down below. And I will see you in the next one.